Good Science Thursday, my friends. This is liable to be a long one and probably going to ramble. And if this thing focuses, you might recognize why. What is an XRF analyzer? Why would you care about an XRF analyzer? X-ray frequency analyzer. So these are things that used to sit in a lab and cost tens or hundreds. Now they still cost tens of thousands, but in the lab they cost hundreds of thousands. And the lab had all kinds of special temperature controls. So it was $1 million lab with a bunch of analyzers in it that did this type of work. So just knowing, experience, seeing labs full of these things doing work and understand what they do 40, 50 years ago, these things don't disappear. The science doesn't disappear. It just gets more precise, more accurate, and a lot more people to know what they're talking about because you can't know all the aspects. So anyway, what's with this handheld XRF analyzer? Why would I use this one as an example? Well, this is in the spectrum analysis world. We're now talking statistical analytics of detector information made into viewable graphs and charts and information that humans can understand. Because if you looked at that detector forever, you would never know what it was doing. If you looked at that graph without knowing the rest, you would know what it was doing, maybe, or not. So why does this matter? Well, I'm talking decades with you. I'm not talking about yesterday and today. So this spectroscopy is very specific sciences, many different sciences put together. Spectroscopy is the measurement of a spectrum within an energy range. So the spectrums include electron energy, its measurements, its measurement types. The spectrum includes optical photon energy, which is the rainbow, and what the rainbow does and doesn't tell us. And if you could look at the rainbow with the right instrument, it would inform us of something. So on the screen, you see Olympus, you see Thermo Fisher. You can go look at another, who is it? The FLIR. FLIR has some amazing instruments. And realize these are all handheld things. They're the size, getting to the size of cell phones, when they used to be a supercomputer connected to an instrument bank, collecting data for months to be able to draw the same graph as this thing is going to show you in minutes. So what is this graph going to show you? What is this spectrum analysis diagram going to show you? If this was in frequencies and electronics and electron measurement, you could apply spectroscopy to the analysis, discrete signal analysis. In this case, the signal in photons is the frequency of the photon energy, not electrons. Photons are made by electron movement, but they're discrete particles, separate from whichever way that electron went that we know now. Complicated, yes. So some time ago, the same nice, friendly influencers that waved Geiger counters around as if they were experts, as if the conversation deserved 5 minutes on YouTube, and no follow-up, no depth. So mispresenting information and sciences is tough. So what does this analyzer do? This analyzer, the Olympus analyzer, XRF, most XRF analyzers are going to work this way. They have an X-ray energy transmitter, a source. It's probably klystron, some type of high energy chamber. Pulse forming network makes a very high voltage that excites electrons and ionizes them instead of moves them with potential differential. Okay, just each one of these. We could go there if you asked the question. But back to, okay, I'm going to be specific. A YouTuber, very respected influencer by some people, Thunderfoot, has gone off on Geiger counters and waved those scientific instruments around. And to me, he made a fool of himself. But whatever your opinion is of that YouTuber, because behind that Geiger counter has to be a spectrometer, a high energy spectrometer. Probably it could be multiple detector types, multiple spectrometers, because that's the science. So we know about this, and my computer just timed out. So yeah, Olympus handheld XRF analyzer, Thermo Scientific Niton versatile XRF analyzer, Hitachi high-tech XRD and XRF analyzers. So some time ago, these influencers went off, and to me, they made fools of themselves, saying that somebody that had a GoFundMe for a surface scanner, an optical emission scanner to detect chemicals or what's on the surface of fruit, thinking that they could make an inexpensive instrument to carry around, and you could go into the market and just maybe scuff a piece of fruit and get a sample off of the fruit to see what's on the surface of it. And it should come back with something like waxes or paraffins and maybe what else. Who knows what that specific instrument could see because of the detectors that would be inside of it. So people poo-pooed that stupid idea of pointing an instrument at something and taking a reading, and at the exact same time, these types of instruments were out there and being developed. FLIR heat sensors have been around for decades. Visual displays, CGI presentation of hard instrument data. That's what these things are. It all comes out to see. A graph is CGI, right? You write it on a piece of paper and take a picture of it. You turned it into CGI. This is how we progress and have progressed. So thermoscientific, you can do this type of threading with any specific instrument type. This was because I had seen the name right up here, Olympus XRF analyzer, while searching for something else. I chased this out because it's an X-ray emissions analyzer and it's portable. I don't see the price of it here. Oh, there we go. There's one for you. Look over there on the right. Thermoscientific Niton XG Analyzer Olympus. A whole kit there for you for the simple price of $18,000. 18,000. You know what is in that? A software information library of specific frequency measurements from X-ray, or in this case, yeah, X-ray fluorescence, optical emissions caused by X-ray fluorescence. So this is an optical emission analyzer that you can point at a rock and find out what is inside, what is on the surface of that rock. This is a type of, it's a surface ablation sampling technique. You can use photons from a laser. You can use directed energy sources, directed plasma burns. So lots of different sampling techniques in here. If I haven't gone past enough rabbit holes, a rabbit hole is a conversation point until you prove it's a rabbit hole. XRF analyzers, XRD, X-ray diffraction, what is XRD? XRX, X-ray fluorescence. So the fluorescence would be when an X-ray particle, when a gamma particle, when an alpha particle, when a beta particle, each one's a different detector, hits something, it can make it fluoresce. It makes it ring. It's a bell. It's frequencies. It's woo. There we go. See how easy it is to go there? This is what made a religion we're all very familiar with, Scientology. This is how you can take and make this shit you should learn or understand or at least respect the speakers, maybe. And don't let it get turned into science fiction and faith and Nibiru. XRF analyzers. So then, right, to make this a longer video, I'm already out at 10 minutes. I haven't been wholly specific other than I'm talking specifically to high energy emissions analyzers. They use high energy particles to ionize, to excite other particles at a very close proximity for inverse squared reasons, and that's how they work. If you understand spectroscopy, if you can go into any of the specific foundations of spectroscopy, optical emission spectroscopy is the oldest thread you will find. It was a foundation thread because visually we saw rainbows. We saw the colors in the skies change. We saw the hues change because we don't see just in black and white. And we noticed that over generations and said, what the heck is going on there? Let's make a god. Because that's how it works, correct? So I could go on with this searches. I would change. I'm confused because I'm videoing a video. But up here I'm at, XRF analyzers. Now let's go there. You've got some time if you've got this far. Let's go for ALPHAENERGY, alpha energy analyzer. Alpha energy, see alpha analyzer. 6,430,000 results in 0.54 seconds. Alpha suite spectrometers. See that word? That word spectrometer? One of the most fascinating words in science and physics, because inside that word is subatomic particle physics. What we learned about after electron flows. 434 energy analyzer, alpha controls and instrumentation, 435. So the best thing here would be pick one of these and then find an expert. But look at the prices on these things. 10,000, 10,000, 10,000. See Alpha Energy Analyzer, sponsored link. 434. So where else could I go up here in my Google land, right? It's in my search land. I want to go to a specific vendor. This outfit is goddamn commie red Trump friends kind of company, because they're not in this country. Most of them aren't. This stuff didn't come out of America, Optical emission spectroscopy came out of the universities of Europe before we were born. Before we invaded our neighbors, the Native Americans, Don't measure nothing, no. Field survey instruments for rock analysis, Olympus, third way. What the hell? Who searches for this shit? Now you're seeing my search list. Who searches for these things? Geology field instrument list, third way. That's a piece of shit search, man. Them jerks. What's the population of America? Sarah Fabian. Oh, that's an interesting one. Major aquifers under Texas. I went there because I'd seen the major aquifers under Texas 50 years ago at Exxon Production Research being studied using optical emission spectroscopy um, and inductively coupled argon plasma sampling techniques. So, no, nothing major. Just the drinking water measurements from under our dirt from 40 years ago. Wonder what's changed? How could you wonder what's changed? This isn't in verse 27, chapter 8 of most books. Energy analyzers, power quality and energy analyzers, hemispherical electron energy analyzer. Holy crap, man. Thermo Fisher, what are those people? So, Thermo Fisher Scientific. Let's do another one, just keeping it in my world, eh? So, here's here's a giveaway. Gerald Ash. Oh, look, it showed up in my search list. I wonder how long. Gerald Ash monochromator, spectrograph, Gerald Ash 82 Ashley Gerald. Who could that be? So, Gerald Ash. Let's use this one. Who is Gerald Ash? People, the collection of historical, scientific. Gerald Ash Company in Boston was incorporated by J.O. Gerald in 1933. So I was down in the basement of that building. You would be friggin' amazed at what is down there. Just at what it is, let alone amazed at what it does to be able to do what we do. So thermoscientific. So when I joined Gerald Ash Company, they were Gerald Ash division of Fisher Scientific, but it could have been Boston Scientific. So Gerald Ash, when I worked for them, were specifically these optical emission spectrometers and the lab sampling techniques and tools and methodology around that. When did I say? Was it 1933? Yeah, since 1933. So, yeah, meeting these folks is impressive. The basement was 8 stories that I remember underground in some of the oldest bedrock that we know of. It cut lines in optical flats to make them into optical gratings. So while I was with this company I traveled, I flew most of the time. 2/3 of the job was flying to another state, landing in an airport, driving 4 hours, and finding a hotel in some order, meeting a new client, assessing the building power, the skills levels of the operators, the ability of the lab comparative to the necessity for cleanliness. It's much different working in a foundry than working in a parts per billion lab. So you go out in the desert to a mine somewhere, and their instrument looks just like the one somewhere else, and when you open it up, it is totally different. Even the software analytics is another license set, another set of software and competencies to be able to use them that are pretty cool. So, history of Gerald Ash Corporation. You can see the name changes through there. So when I was working for them, that was the specifics. The task of the job was these instruments, their applications, and their specialties. I would have had a region that would have covered all of South America and already did cover most of the southern states, southeastern states. So one day it was at a supplier doing scrap metal work. The next day it was at JPL assessing an analyzer, adding a channel, or down in the bowels of NASA. The client list is Fortune 100s. That's who had these instruments. The client list are the top 10, top 100 universities in the nation. So Gerald Ash, while I was there, and I had the Texas region, and nothing in Texas is close. Half of my Texas flights I had to fly because it was a 4 to 8 hour drive just in the state of Texas to get there. So I loaded up my baggage and carried a Halliburton high security case and went off on my business and passed through airport securities and was a good guy, not a bad guy. That's what happens. That guy next to you on the airplane, your neighbor. So this company, Gerald Ash, got bought out. They got bought out by another instrument company, and that instrument company had a more full process line, and I knew what their process line and knew that I would lose a lot of field travel and work a lot more locally in the chemical refineries in the area. So while I hadn't worked in a chemical refinery at the time, I did know that it would be an interesting job and that somebody else kind of needs to take it. So the person that took my place got a new company car, which was a Ford Escort or a Ford Pinto station wagon. It did have air conditioning, but when they called me and told me they were going to give me a company car, I told them to find the person that was going to drive it, and I was giving them 2 weeks notice. So I met the young man and handed him my Halliburton case and some list of a few deadly test elements that were in there for instrumentation, a few very expensive photomultiplier tubes that were spare parts with specific applications. Before he needed to contact our office, find out what they were. So yes, I had one of the most fascinating jobs you could ever have if you enjoyed traveling heavily, and I left for something different. So went back to work in non-destructive oil field test industry. So whole nother story. There you go. There's 22 minutes. It started with a specific instrument talk and why I can specific instrument talk. But this type of conversation, this type of thread is available. I did not do spectrometers. I did mention I was going to go to one more. Let me do this one quick since you're already hung up. This one is that commie Russian outfit I was speaking to. I got contracts and bids. Now, the way I found this is P-L-I-M-A-S-T-E-R, Polymaster. All right. Radiation measure and radiation detection devices. So I've been visiting this site and its competitors, which are 7 to 10 companies across the planet. My detector, the power supply was built by one of those top 10s. That's why I trust my detector and understand what can go wrong and will know when it's going to have to be fixed or repaired. And in that, I'll make a note, whatever time and date that happens, and reuse it and see if all my readings are the same. So this Polymaster outfit, the way I found Polymaster was maybe 10 years ago. So I was researching our federal document archives and stores. I remember I quit under duress. Let's call it a mental breakdown, a psychological break, a sum of too much and too many straws, right? So here is where I went. I read the United States Protective Action Guidelines. That is another 5-minute video that is a thesis and a doctorate. So that radiation portal monitor that went by, I took some time and went out to the Hanford site, and one of our institutions that I trust for what they do, I don't trust for what they share, because I've seen these portals in development. I was interviewed to see if I was an intruder out in Hanford by someone in a parking lot that noticed I was paying attention to the future generation of what's going to look for radioisotopes in our container and shipping supplies. They're going into almost every international port and terminal and airports to look at our baggage, to look at our shipping, to find that cocaine store. Now, cocaine might have specific responses because of frequencies to energies that these detectors could get into, if maybes. And these maybes I offer quite a bit. So you've watched that scrolling by maybe as I've spoken to it. Where I found these was chasing out Federal Protective Action Guidelines for a radiological emergency. They have a list of equipment. I say we have a list of equipment suppliers that have been tested and are certified against the requirements in response to a frigging nuclear disaster. So those PAGs describe the actions, describe the approvers, describe the funding levels, and who has to even make the first signatures for any of these events to occur. This is how bureaucracy and federal governments and federal agencies and any corporate kind of structure that uses science to run that uses knowledge to run their business. So this outfit was found by looking at federal action PAGs, reading through those. One of the sequiturs to those PAGs is training done by Lawrence Livermore National Labs on radiation dosimetry. That is another video in my list, and a word I'm forgetting, it'll come to me later as these things scroll by. So chasing through that, I went to our federal acquisition systems and I looked up who the approved vendors are and who has won the contracts with federal agencies for this type of equipment. Now, among those agencies for this equipment are state and local responders. What you see going by on the screens, on the monitors, are state and local responsibilities. Our state's responsibilities to fund the equipment that first responders need. So why does this matter? I'm almost at an hour. I've talked past so many things. There's no bombastic. I didn't get a haircut to tell you about these secrets. This outfit, Polamaster, specifically 10 years ago, has an instrument that fits the guidelines that we are looking for, not me, that should be used for radiological assessments. It is how professionals that do not speak to this would respond in an emergency. They would go out in an area, or they would put this meter on the back of a remote control device and have it go scan an area, because they don't want to get killed. They don't want to have mutated babies. They are trained in the risks and also are accepting the risks of their job and their great paychecks. Now, these aren't politicians. These are soldiers. These are first responders. This is you and me in a disaster situation. And the person with the knowledge and the training is the one that either is the hero or the person next to you. I took a break to let that sink in, because Heroes is another video in my 200 video series now. Thank you if you got this far. Radiation portal monitors, radiation detection and identification. When I looked at the specific meter in here, asked that question. What I found was there is licensing for the analytic software to be able to make more sense out of the data these instruments can tell you. I mentioned in my first video, I think, this is complicated. I mention in every video that I apologize for not going wherever you think it ought to go. And thank you. If you got this far, if you took this time, this is Physics 903 course. This is top-down physics from the application experts, the professionals in the field, my peers. That word peers, the importance of it, the weight of peers. What is a peer? If I am in a protest crowd, I am a peer. That I'm in that protest crowd means that I have a position. Otherwise, I don't go to these protests. I'm there in spirit. But if I'm there physically, if your life is in danger, no matter what kind of shoes you have on, there are people just like me with shoes on that are your peers and next to you. Then there's another peer that's taking a video of whatever's going on. And there's another peer calling 911 because they saw that people are taking videos and forgot to call 911. And the screen times out because, God, this is boring to go through. So, physics, an introduction to. If you want a university to go to, let's talk about it. You have to have the wherewithal to sit through MIT's nonsense. And if you sit through MIT classes, these are decades old information. What they're telling you is something new that we learned more about decades ago. Homeland security, nuclear power, oil and gas mining, industrial safety, medical, environmental radiation monitoring. This is where just a fraction of my head is. So yes, let me flip my hair and offer an utterance of cleavage. Would that help? Would that help? If you know a good psychologist, they're invited too.